This is my brief biography. You might conclude from looking at this that I'm old, and you'd be right. The thing that got David's attention was my novels. I'm not quite sure how he discovered them, but I'm delighted that he did. These are the two novels. If you're seriously interested in how climate change works, The Plot to Cool the Planet talks basically about the politics of it all and how somebody who isn't the President of the United States might actually make something happen. And I recommend that. And I recommend, my second book is more recent. It's shorter, it's more oriented toward the people than the problem. And from my point of view, not necessarily as interesting, but I think it reaches more people. I think you also should consider reading Kim Stanley Robinson's novel, Ministry for the Future, which has a lot of interesting ideas, a lot of creative thoughts about how to make society get to where we need to get. Inevitably, I guess, I find some of the time frames and the proposals overly optimistic, but it's well written and it's got some interesting stuff in. My books are both available on Amazon, by the way, and I encourage you to get them from Amazon and get them online. You can also get it from Barnes & Noble if you're sensitive about that, or there's something called bookshop.org, which is a coalition of bookstores that carry books and send them out, but they only do paperbacks and book and hardcovers. They don't do electronic versions, but they share all the profits with local independent bookstores. So enough of that. I came to hear about the climate disruption problem. First I should mention, aside from the recording that's being made now, I have put this into my slides into a URL, and I will give that to you at the end of this show, by which time it should be online. I hope it will be. Mm-hmm. I urge you to read the latest IPCC report. It's from February 28th. The summary is only 38 pages, but you will learn a lot from it, I believe, if you don't already know all these things. And they have new ideas about some things, which are very interesting, and some better data than they've had before. But we know the short story. We've been burning fossil fuels. The level of carbon in the atmosphere is double, almost. We're on our way there. And we're already seeing the effects: polar and glacial ice disappearing, oceans rising, storms, floods, forest fires, and so on. The IPCC answer, which I call the policy prescription, they never use that term, but I think that's how you can describe it. If we make a major effort, we can end net fossil fuel carbon emissions. Notice the word net, not all, by 2055, and meet the goals of limiting global average temperature increase to 1.5 degrees Celsius in 2100, and limit the worst effects of climate disruption. That's a nice goal, and we need to do all of those things. In fact, we should have done them a long time ago. But my real primary reaction is their policy prescription is dangerously incomplete. And this is something that we really need to educate people about. Historically, the IPCC focused on conditions in 2100, not on the near term and the midterm, because it was thought to be a problem for for the next century. But the reality is that we're discovering that global warming is causing irreversible damage, like melting glaciers that once they're gone, they are gone for as far as we can see into the future. And potential tipping point risks, which we're becoming aware of, but haven't really quantified or documented the way we need to. The IPCC hasn't ever really addressed these kinds of problems. It's been basically trying to focus on how we can get to 1.5 degrees Celsius by 2100. That's why they wrote the 2018 report. It was a political commitment made at one of the IPCC conferences. So I think we're missing out because we aren't addressing the problems that we are going to face really in our lifetimes and the lifetimes of our children. So let's take a broader look beyond fossil fuels here. This chart, which I've never seen any place except at the Singapore biosphere, and this is a photo I took of it, really gives you a much better sense of what we're up against. This is yearly man-made and natural carbon emissions in gigatons, all right? And you start at the right, you've got the oceans, which are supposedly in balance, producing 90 gigatons into the atmosphere, and absorbing about the same amount. That's the red arrow is the release, the green arrow is the capture. But what we're learning is that as the ocean gets warmer, it isn't absorbing as much carbon. The next item is soil respiration. This is what the soil gives up as plants decay. Plants, when they're growing, absorb 120 gigatons of carbon a year. And that's offset in part and increasingly in larger parts by forest fires and by animals. And we have a lot more animals on the planet, not natural animals, but domesticated animals that we eat, basically, either directly or indirectly. And as the population of the Earth grows, the animal population is growing even faster because basically everyone wants to eat like an American, which is, can't recommend that, but that's what's going on in the world. And then there are the more direct effects of human activity, direct negative effects, that is, effects that release carbon. There's deforestation, 1.5 grams. People, we've got 7 billion people on the planet, and we breathe out carbon dioxide. And of course, the projections are that we'll have 9 billion people by 2100, and that's if climate issues are managed well. And I'm not at all convinced that will happen. Then the last three on the far left are the things that use fossil fuels, residential and office and urban buildings, transportation, buses, trucks, cars, airplanes, ships, and industry. And that has been really the primary focus of the researchers and the IPCC. In fact, until a decade ago, they weren't even looking at ships or aircraft. And guess what? When they did, they discovered there was a lot more pollution coming from them than they anticipated. So this is where we are, but all the trends are in the wrong direction. All right? Much more forest fires, more domestic animals, much more deforestation, population growing, and despite all of our efforts, we haven't stopped the use of fossil fuels. In fact, it continues at higher rates. So that's where we are in a broader sense, okay? Not a very promising picture, but the IPCC thinks that we can get to 1.5 degrees centigrade by 2100, even with all of these problems. Here is, however, the chart that is in the 2018 report on attaining the 1.5 degrees centigrade goal. And if you look at the far right, you see the purple band and the gray band and the green band. Those are the most probable outcomes given certain presumptions that they make. If we can move the net zero deadline from 2055 to 2040, we can get down to this green level. If we don't control carbon methane and other non-carbon dioxide emissions, we're going to be way up here near 2.0 all the way through. But they never really talk about this period between 2040 and 2060. What they might have said is, there's nothing we can do, which they have now finally said in the 2022 report, to avoid getting higher readings in higher temperatures in the near future. The idea was not that we were going to go up to 1.5 by 2100. It was that we were going to come back down to 1.5 by 2100. And it is this area, I don't know, you can see my cursor, I guess.
Yeah.
This area here is what we're going to live through, we and our children. This is the period up to 2060. And it is the most dangerous period when you consider the immediate effects of the heat. So the other half of this chart is the next slide, which shows, yes, if we can cut it back from 2055 to 2040, we do better. And if we can cut down on methane primarily and nitrous oxides, we can also get away from that purple curve, which is the least favorable. Frankly, I have to say, given the political situation in the United States and in the rest of the world, I don't think we're going to meet any of these improvements. So it's not very encouraging. Now, in the 2022 report, which just came out, they actually make a table out of this. They've got 5 scenarios that the IPCC has developed to show best cases, medium cases, worst cases. And if you look at these numbers, you don't see anything where the best case is below 1.5. And that's in the coming 20 years. All right, that's between 2021 and 2040. And it gets worse when you get to the midterm. By 2041, the lowest best estimate is 1.6 degrees centigrade. And the worst is 2.4 degrees centigrade, which is way over what anybody thinks is survivable over the long term. And whether we can make it through that 20 years from the midterm is really a question. The long term, well, the bottom curves get way out of control. The only one that's under 1.5, though, is the most favorable option. And even that's their estimate, but their range is between 1 and 1.8. All right. Obviously, all this is statistical presentation, calculation, probabilities. And the difficulty is that when you start projecting out as far as 2081, there's a lot we just don't know, and it's harder to believe any of this. But the point is that the most dangerous times are the near future times before we get to 2100, and that was never really recognized in the IPCC reports, and is only partly recognized in the newest ones. So what I take away from these 2 reports is that we face at least the 25% probability that the Earth's temperature will rise to 1.75 degrees centigrade for a large part of this period. It might be still above 1.5 degrees centigrade in 2100. So the question is, what are we going to do about to avoid the irreversible damage that's taking place right in this period before 2060? And how are we going to evaluate and try to deal with the tipping point risks that we'll face then? So I will leave this for you to read later, but we know that under their predictions, temperatures will level off only after we get to net negative or net zero total carbon emissions. And that's around 2055, they now estimate. They used to say 2050. And we won't even know if it's worked for another 20 years because of natural variation and trying to figure out if the battleship has been turned around, if you will. Okay. And the biggest immediate problem is to control methane. And once we started looking at that, we discovered there's a lot more methane emissions than we ever counted. And there may be others as a result of some tipping point problems. So this is what we're up against, and this is what is serious. Now, beyond that, so I'm going to look at for a few minutes at the current temperatures are already dangerous, and then look at tipping points. A recent study shows that this is just one of those mind-altering kinds of things, that over the past 6,000 years, humans have lived in an area where the mean temperature, the annual mean temperature, ranges between 50 degrees basically and 60 degrees, which is 10 to 15 degrees Celsius. So keep that 10 to 15 degrees Celsius in mind when you think about where we are these days, these summer days in particular. And the authors conclude that this reflects a fundamental constraint on the temperature range that's viable for humans. And if that's the case, and if we have temperature increases of 1 to 1 3/4 degrees Celsius, about 1 to 3 billion people will be living outside this range over the course of the next period to 2060, 2070. And it means that people will be exposed to annual temperatures warmer than nearly anywhere today and not survivable probably. So nobody in the IPCC is talking seriously about these kinds of issues that are in the last bullet on this page. This warming suggests that up to 35% of the Earth's people will attempt to migrate, either internally or internationally, to new locations, because where they're living is not sustainable. This in turn, think about what the politics and the sociology of this is. This means greater hostility toward refugees. It means civil and international conflict over land, food, fisheries, and it means more of a closing of the gates, travel restrictions, trade barriers, and higher levels of violence of every kind. So the question I want to ask is, what kind of a world are we going to have by 2060, or even by 2100? Will we even recognize it? It's not a very appealing subject, and the IPCC, they've said about as much as I've said in this paragraph. Interestingly, the U.S. Defense Department has identified climate change as its primary security worry and threat. And it's because of these issues at the bottom of the page. There will be wars over land. If people in China who are starving decide to move north into Russia, how will Russia react to that? We already know how the Western Europeans are reacting to immigrants, refugees, and the United States for that matter. And it's not a very pretty picture. It doesn't suggest peaceful times ahead. This is just a map that shows all these striped areas are areas where the temperature is going to be so high that it's difficult for people to live, basically. And the black areas are simply impossible. These are mean annual temperature numbers. The little blue box at the bottom that I've put over the temperature gauge is that 10 to 15 degree range that is truly habitable for human beings over a long period. So, is this dangerous? Well, we already know some of what's going on. We can see dangers in terms of melting permafrost, in disappearance of species of all kinds, but fish species that are vanishing from the seas, which have traditionally made up as much as 40% of most people's diets, their protein source. And we know about the forest fires that just keep getting worse by the day, or at least by the year. Mm-hmm. So this Professor Ramanthan at the Scripps Institute of Oceanography made this statement that's at the bottom. You want to know how to define dangerous? Since that's one of those things, what does dangerous mean? I think nature is answering that question. We have already reached a dangerous spot. And that's a statement that was made in January of 2020. It was in the Washington Post in January of 2020. So we've got problems, and they're not going to get better, they're going to get worse. Now let's talk about tipping points. What I'm quoting here is a letter from Kelly Wanser, who is the head of an organization called silverlining.ngo, which is interested in these kinds of problems, is interested in what we can do, mostly in various forms of geoengineering, to try to avoid tipping points and to avoid drastic temperature increases that melt all the glaciers, make a lot of species extinct, and so on. So, but you'll notice if you read this, there's no quantification in any of this because we don't have it, all right? Heightened risk that several major natural systems are approaching thresholds for rapid, potentially irreversible changes. Well, we don't have any data that's systematic to go with that. We know specific examples. We know that the rainforest is in deep trouble in the Amazon. We know that permafrost is melting and it's now allowing fossil natural gas, fossil methane, to leak up into the environment, which nobody thought that's what was going on with these permafrost methane bubbles, but it turns out they're not all from the surface. They're from deep down as well. Precipitous collapse of polar ice sheets, we've all heard about that, it's so dramatic. Rapid coral reef die-offs, also very dramatic. And without coral reefs, you don't have good fisheries because the fish mostly spawn and grow to a lot of reasonable sizes in coral reefs, and the larger fish eat those smaller fish. And finally, the ocean currents are at risk if Greenland's glaciers really stop pouring cold water into the ocean. So, how many of these are there? Are there others that aren't on the list? Do we know when or how any of these things will happen? No, that's the problem with tipping points. And it could any one of these could be a dramatic change in the whole climate picture. And here's what she said in this letter that she sent to their members. The processes underlying many climate tipping points are hard to represent in climate models and are underrepresented in climate projections. And of course, she's talking about the IPCC here, but she doesn't say so in so many words. We do not understand the near-term catastrophic risks very well, and we are likely underestimating them. Even if these risks are low, the enormous magnitude of their potential effects warrants far greater investment in information and preparation than the current policies call for. And that's where we are, basically. So what examples of near-term and mid-term tipping points? Two specialists in Amazon environment made a statement in Science Advances a couple of years ago, in December of 2019. This is a quote: "The precious Amazon is teetering on the edge of functional destruction, and with it, so are we." That's as clear as it can be, isn't it? Today, we stand exactly in a moment of destiny. The tipping point is here. It is now. All right, so that's the Amazon. When you talk about the Arctic permafrost beginning to release methane, both contemporary and fossil methane, that is very destructive because methane is much more powerful greenhouse gas than carbon dioxide. And if we look at Greenland's ice sheet melting at an accelerated pace and what might happen with the Antarctic ice, we see that important parts of the climate system may be moving toward irreversible changes at a pace that defies earlier predictions. That is from this December 20, 2019 Washington Post article. So what's the answer? Well, I think to start with, we need to have a broader policy prescription. We've been focused on 2100 and how we can get to 1.5 degrees there as if that was some kind of magic, without thinking about the fact that we aren't going to get there without going through 4 decades of temperatures above 1.5. And that the question is whether we can ever get back down. And yes, we need to do everything that the IPCC is recommending. We need to accelerate progress towards zero net carbon emissions from fossil fuel and from other sources of atmospheric carbon, like animals and agricultural practices that release more carbon than we would like. But we're still facing the dangers of irreversible damage, like species extinction of plants and animals and insects, and tipping points. And the first step is we need to study these problems and begin to figure out what these risks are, how big they are. The fact that there's some lake in northern Canada that's leaking fossil methane, is that one of a kind, or is that something that's happening all over the permafrost region? How much methane are we actually putting in the atmosphere? And what can we do to prevent it when a lot of it is coming from abandoned oil wells? So those are the kinds of questions that we need to get answers for, and quickly, and we need to take it much more seriously than we do. So that's my presentation.